Welcome to Lesson 4.2, Understanding IP Convergence and Extensibility. In your Candidate Information Bulletin, we are in the Communications and Network Security domain. We are at Key Area of Knowledge A, which is Apply Secure Design Principles to Network Architecture. Our topics are going to include IP Convergence, IP Extensibility, an Introduction to VoIP, that's Voice over IP, MPLS, Distributed Network Protocol, and Fiber Channel over Ethernet. So let's start with IP convergence. IP convergence is the use of the Internet Protocol IP as a standard transport for transmitting all information, voice and data, music, video, TV, teleconferencing, anything you can think of. So we're really moving away from using lots of different circuits and different communication channels to saying we've got one standard transport that we're using for all of these things. That introduces standardization. And the more standardization we have, the more simplicity we have, right? The less chance we have for misconfiguration, and also the easier it is to consistently apply security controls. It also reduces the number of service providers. If all of these things are going over IP, well, now we're not dealing with different service providers, which reduces the amount of due diligence that we have to do. But conversely, it increases our dependency for availability on a specific provider. So it's a double-edged sword. Also, by having one service provider, it does introduce a single point of failure, and it introduces consolidated attack vectors. So we've got the good with the bad. Extensibility is additional functionality or the modification of existing functionality without significantly altering the original structure or data flow. When we talk about IP extensibility, it just means we can add on functions, but we leave really the basic IP protocol and protocol suite intact. We can do some of that with IP4. IP6 was designed from the ground up to be extensible. Open standard is a standard that's publicly available and can be freely adopted and extended. So when we talk about open standards, they're one that anybody can work with, and that you can see the entire standard. It's all been published and available. It's not patented. It's not a trade secret. Voice over IP, often known as VoIP, is the transmission of voice traffic over an IP-based network instead of using traditional analog circuits. VoIP is also the foundation of more advanced communications technologies such as web and video conferencing. VoIP is based on a protocol called the Session Initiation Protocol, or SIP. SIP provides integrity using MD5 hash functions so that we have message hashing on both sides. That's how we're providing integrity. SIP supports encryption mechanisms such as TLS. Any SIP device can talk to another SIP device. Multi-protocol label switching is also known as MPLS. And MPLS is a relatively new, scalable, protocol-independent telecommunications transport protocol. Now, what's really interesting with MPLS is that data packets are assigned labels or tags. We have MPLS label edge routers, they're known as LERs, that make packet forwarding decisions based on the label content. So a data packet gets a label, and our MPLS label edge routers decide how they're going to forward that packet again based on the contents. We have end-to-end circuits can use any transport medium and any protocol because it's protocol independent. That works inside an MPLS network. Now, an MPLS network, though, does have to interconnect with a traditional IP network. The LER at the outbound point in the MPLS cloud will remove the label and forwards the packet using standard IP routing information. We're seeing MPLS being used more and more often in private cloud networks. And what's important to know is that you can have an MPLS network that you're using for your organization, and then that MPLS network can easily connect to the rest of the IP environment. Distributed Network Protocol, or DNP3, is a set of communications protocol that's used between components in process automation systems. DNP3 was designed for reliability. So here the concern is that we're using these in process automation systems. Those were our industrial control systems that we already identified of having a number of weaknesses. And then we have this protocol that was never designed for security. It was designed for reliability. So we want to keep that in mind when we're assessing our ICS systems. And then lastly, we have fiber channel over Ethernet, which is FCOE. Fiber channel Ethernet is primarily used for data center storage networks, or SANs. FCOE, network IP traffic, and storage, SAN data traffic, can be consolidated using a single network. We don't have to use multiple channels, we can converge them. This consolidation can reduce the number of network interface cards required to connect disparate storage and IP networks. It reduces the number of cables and switches, and it can also reduce power and reduce cooling costs. So fiber channel over Ethernet, FCOE, is how we're going to converge network IP and storage SAN data traffic. So let's review what we've just talked about. In our Lesson 4.2 review, we started talking about IP convergence. Then we talked about IP extensibility. We did a brief introduction to voice over IP, and in later lessons we're going to go much deeper into voice over IP. We talked about MPLS, DNP3, which is Distributed Network Protocol, and lastly fiber channel over Ethernet. You want to make sure for your exam that you have at least a high-level understanding of each of these topics. So let's do a match the meaning. Down the left-hand side, we have VoIP, MPLS, DNP3, CISSP, LUR, a label, and FCOE. So I want you to take the time you need, put me on pause, match up the terms, then come on back, and we'll go through them together. All right, let's go through our 4.2 terms. VoIP is transmission of voice traffic over IP, the move from traditional analog circuits to using IP as a transport medium. MPLS is a protocol-independent telecom transport that can integrate with IP. DNP3 is the protocol used for process automation communications. Our CISSP is the protocol that we use on voice over IP or VoIP networks. A LUR, which is a label edge router, is the router used in an MPLS network. A label is a replacement for a header in an MPLS network. So instead of the traditional IP header, we have a label. And FCOE is what we're using for storage area network, or SANs, data channel over IP. We're going to end Lesson 4.2 with our 3 CISSP exam tips. The first one is that extensibility is new or a modification of existing functionality without significantly altering the original structure. That's going to be our definition of extensibility. We said we have some of that in IP4. It's really built right into IP version 6. An open standard is a standard that is publicly available and can be freely adopted and extended, and that MPLS networks interoperate with IP networks. So those are your 3 tips. So thanks for joining me for this lesson, and I look forward to seeing you in the next.